Hearing loss represents a variety of disorders. There are several extremes to it, from people who have mild difficulty with understanding speech in a noisy background to people who can't hear speech at all. For most people, hearing loss creates difficulties in communication, but for many people, tinnitus is a major problem. In fact, many people with hearing loss first notice tinnitus as their initial symptom, and that's actually what brings them to medical attention. Tinnitus represents an extreme problem for a large number of individuals, and there's an organization known as the American Tinnitus Association, which funds research in tinnitus. I serve on the scientific advisory committee to this organization.
Hearing is our most important sense and the basis of human communication. Without hearing, using the telephone, enjoying music, listening for a baby's cry, it's just not possible. Without hearing, we're isolated.
I think hearing loss is very different from many of us, because we see people, they're walking around, they look perfectly normal. We don't realize that they suffer from hearing loss. And so when you see someone who's blind and they're tapping around with a cane or they're fumbling around, you're really aware that they have this difficulty. And the problem with hearing loss is you're not actually aware anyone has a difficulty until you're trying to communicate with them. And then sometimes you don't even immediately pick it up that they're hearing impaired. You might pick up they're not understanding you, or maybe you think that they're not very smart, or they don't speak the language or something, and you think if you say things louder they'll hear it. But it isn't that easy.
Well, what you hear going on behind me is where all of us want to be at one time or another in our life. We want to be a part of the social scene. But if you have hearing loss, it's very difficult, and you miss a lot.
At the University of Washington's Virginia Merrill Bloedel Hearing Research Center, scientists are working on the Hearing Regeneration Initiative, an effort to find the molecular keys to restoring hearing through hair cell regeneration.
Well, in the United States today, about 10% of the population has significant hearing loss. At birth, only one baby in 1,000 will have a severe hearing loss, but by the time we get into our 70s and 80s, over 50% of people are affected. And basically, we live in a noisy world, and that damages our ears cumulatively over time. That plus aging leads to hearing loss as being almost inevitable if you live long enough.
Most hearing loss results from damage to inner ear hair cells. Hair cells are both sensitive and fragile. Loud noise, aging, medications, trauma, disease, and genetic conditions all can destroy hair cells, resulting in hearing loss. And we risk many of these conditions almost every day. In 1987, Dr. Edwin Rubel of the University of Washington's Virginia Merrill Bloedel Hearing Research Center discovered that birds regrow hair cells spontaneously after being damaged.
One of the great things that happens to a scientist once or twice in their life, possibly, is to make a discovery that actually results in a new field of science. And this was such a discovery, and this is the most exciting thing that can ever happen to someone like me.
This extraordinary discovery, confirmed by other scientists at different universities, has led to a worldwide effort to understand cell growth in the inner ear of additional species. scientists now believe that human hair cells can be coaxed to regrow just like birds. Progress over the past 15 years has been full of promise. Dr. Rubel and Associates recently proved for the first time hair cells in mice can be induced to start the regeneration process. While substantial progress has been made toward establishing hair cell regeneration as a means of treating hearing loss, the worldwide effort has a long way to go. Hair cell regeneration has gained little attention, thus keeping it from gaining needed funding. In order to develop a treatment application that can be applied to humans, we need to expedite basic research and hasten recruitment of pharmaceutical companies. At the Virginia Merrill Bladel Hearing Research Center, under Dr. Rubel's leadership, a group of investigators continue their effort at moving hair cell regeneration research forward. This group is composed of individuals who have invested in hair cell regeneration research for 15 years.
So when we made this discovery, we now had to step back and we had to say, what's next? How do we turn this into reality? How do we actually make hair cells in the human cochlea become new after damage or after genetic diseases? Well, we took two approaches, and the field has taken generally two approaches. One approach is to find out the exact mechanisms whereby this happens in birds and see what is missing in mammals. The other method is to try and figure out what the individual cells do in mammals that surround the missing hair cells and make new hair cells. Those two approaches form the core of the investigations of the HRI, so that the most appropriate people can be doing the best studies right now, and we can share those instantly with the next most appropriate people to do the next most appropriate and most exciting studies. That's where we're going to be able to make new hair cells populate the human cochlea sooner rather than later.
The University of Washington is participating in a multi-center clinical trial of the nucleus hybrid cochlear implant. Hybrid cochlear implant technology is revolutionary in that it allows us to place cochlear implants into the ears of people who have some residual hearing. In other words, they have some normal functioning hair cells, and we're able to place these implants without destroying their residual hair cells, which is something that a standard cochlear implant does. One of these patients were just both connected to their speech processors a week or two ago. One of them is already doing quite well. The other two are still in the learning phase, where their brain learns to integrate the information from their normal cochlea with that from their cochlear implant. This procedure is exciting because it allows synergy with the Hearing Regeneration Initiative. It is much more difficult to regenerate hearing than it is to regenerate hair cells. So it is likely that the first application of this technology will be to enhance the function of cochlear implants. And it's likely that some sort of hybrid implant will be the type used in these individuals.
Hair cell regeneration is not possible today, but with your help, it can be tomorrow. There are some things you just need to hear.
I love you, Grandpa.